This is a counting circuit, and when this button is pressed, it can both count up and also down. This is the dual-digit breadboard prototype version. And this is the final PCB device version. This counting circuit is made up of a few main parts. The first part is a button input press, which starts a NAND gate oscillator using a 4011 chip, and it outputs a square wave oscillating clock signal, which is used throughout the circuit. The next step uses a 4017 chip. Every time the square wave oscillating clock signal input reaches a high, it adds a number as seen in this photo. However, each output is still just a signal and doesn't represent an actual number yet. As you can see in this visualization using a decade counter and a bar graph, it seems like it counts from 1 to 10, but in reality those are just single 0 and 1 outputs going into each pin of the bar graph. This next stage adds our third chip of the counting circuit, the 4510. This chip takes inputs from the previous chip, the 4017, and converts it into a 4-bit binary real number output. If you know your binary numbers, you can see that this counts from 0 to 9, and if not, you can also look at this chart here. For more information on each chip and its functions, as well as the counting circuit in more detail, you can refer to the design engineering report for this project. The fourth and final chip in the counting circuit is the binary decoder, otherwise known as the 4511 chip. This converts binary numbers into signals for a 7-segment display, which produces a readable number. If you copy exactly what is done on the 4510 chip and the 4511 chip into a second digit, then you can have a 2-digit counting circuit that counts from 0 to 99. To do this, every pin is wired up the exact same as it normally would be. However, the carryout pin from the first 4510 enters into the clock signal pin on the second 4510, and the up-down pin is also linked up with the first 4510, so it can all be controlled up and down through one switch. The result of this is a dual-digit counting circuit that has one button input to get it going, and one button input that will reset the tens digit, as well as a 3-way switch that controls the up or down counting. The final PCB version of this project in a 3D printed case carries out the exact same function with a 3-way switch and a 7-segment display, however is limited to one 7-segment display, meaning one digit. However, it is using the exact same Core 4 chips and the same NAND gate oscillator to power the whole thing. Thank you for watching this video to the end, and if you would like to learn more about the counting circuit, you can look at my design engineering report, which has a more detailed description of the project.